Textbook chapter section 8.2 and question number 18. Sample size for housing prices. A government survey conducted to estimate the mean price of housing in a large metropolitan area is designed to have a margin of error of $10,000. So we already have a value of margin of error that is to be obtained, and then pilot studies suggest that the population standard deviation is 65,500. So this value is the population standard deviation sigma. Estimate the minimum sample size needed to estimate the population mean with the stated accuracy. With the stated accuracy means with this above margin of error. So now we know from our previous discussions that within plus minus 2 standard deviation of the x bar distribution, minus 2 standard deviation of x bar distribution, within this plus minus 2 standard deviation, 95% of all the possible sample means that we can construct will exist. Only 5% of the sample means will be outside this range. Just a few of them will be outside this range. And that's the same thing as saying that this true population mean will be within plus minus 2 standard deviation of x bar of 95% of all of these possible x bars. All of these possible x bars will contain this true population mean within their plus minus 2 sigma distance. So having said that, if we randomly pick any of these possible x bars, we are 95% sure that within plus minus 2 sigma x bar of that particular sample mean, we will have our true population mean. So that being said, let's figure out the 95% confidence intervals margin of error. So for 95% confidence interval, we know now that the margin of error is equal to 2 sigma x bar. Okay, so this is the margin of error, for example, and this distance is 2 sigma of x bar distribution. Now I also know that the sigma of x bar distribution turns out to be the population sigma over square root of my sample size that we did several times through our class lectures. So now in this equation I can plug in the margin of error to be 10,000 as given in the question. And I can also plug in the population sigma 65,500, and then solve for n, because in this equation there is only one unknown, which is n, which we can solve for. So if I multiply both sides by square root of n, then I get 10,000 times square root of n is equal to 2 times 65,500, and then if I divide both sides by 10,000, I can get square root of n is equal to 2 times 65,500 over 10,000. So now if I plug in these values on a calculator, that will give me the value of square root of n. So let me just plug this in. 2 times 65,500, divide that by 10,000. So that's 13.1. That's 13.1, turning out to be the value of square root of n. So if I want the value of n, I'll have to take the square of 13.1. So let me use my calculator to raise it to the power of 2. That simply means I'm just multiplying 13.1 by itself. So let's just multiply 13.1 by another 13.1 to give me the value of 171.61. 171.61. But number of observations should not be a fraction, so we can just round this value up to the next possible whole number. So that is going to be approximately 172. So that should be my sample size to obtain a margin of error of 10,000. You could, however, directly plug in the value of n that we can derive from this equation, and we showed in classroom that after a little bit of manipulation, the value of n turns out to be 4 sigma square over the square of margin of error. And in this equation you could just directly plug in the value of sigma and margin of error to find the value of n2. Whichever way is convenient for you, just do it in your own way, you'll get the same result. Thank you, and I'll come to you with a few more answers whenever I have some time. Bye.